The biological explanation for schizophrenia. Describe and evaluate the biological explanations for schizophrenia. AO1. The biological explanation proposes that schizophrenia has a physical cause, which can be explained through genetic defects, chemical imbalances, and abnormalities in the structure of the brain. There are three parts to this explanation: genetic theory, dopamine hypothesis, and neural correlates. Genetic theory. The genetic theory doesn't suggest that there is one single schizophrenic gene, but polygenic, which means a number of genes, which are responsible for the onset of the disorder. However, different studies have identified that there are a number of candidate genes to be linked with schizophrenia, as well as it being etiologically heterogeneous. This means that different combination of factors can lead to this condition. These genes are linked to the increased risk of schizophrenia. Also control the functioning of dopamine. Twin studies of MZ twins are predominantly used as they share 100% of the same genes, which makes it more reliable when establishing whether there is a genetic link. AO3. Evidence to support the genetic theory comes from Gottsman. He looked at the genetic link of schizophrenia in relatives. Gottsman found that dizygotic twins had a 17% diagnosis, whereas monozygotic twins had a 48% diagnosis. He argues that the closer the genetic relationship you have with someone who has schizophrenia, then the greater chance that the family member will also be diagnosed with the condition. This increases the validity of the biological explanation to schizophrenia. A strength. Due to issues with twin studies and shared environment, psychologists look to adoption studies to entangle the contributions of genetics and environment. A longitudinal study by researchers followed Finnish people who had been adopted before the age of 4. Of those whose biological mothers had schizophrenia, the concordance rate in the children was 7%, compared with 1.5% where there was no history of maternal schizophrenia. The study suggests that even when environmental influences are eliminated, the effects of candidate genes are still persistent, thus strengthening the validity and support for the biological explanation. Dopamine hypothesis. So hyperdopaminergia in the subcortex is the original version of the dopamine hypothesis. It states that there are high levels of dopamine activity in central areas of the brain, i.e. excess levels of dopamine in Broca's area, which is responsible for speech and can explain poverty of speech. Hypodopaminergia in the cortex is the revised version that states that there are low levels of dopamine activity in the brain's cortex, low levels of dopamine in the prefrontal cortex areas, which are areas involved in thinking and decision making, can explain the negative symptoms. Evidence from treatment. Evidence to support the dopamine hypothesis comes from the success of drug treatments that attempt to change levels of dopamine activity in the brain. The basic mechanism of antipsychotic drugs is to reduce the effects of dopamine, so reduce the symptoms of schizophrenia. For example, researchers carried out a meta-analysis of 212 studies that had analysed the effectiveness of different antipsychotic drugs compared to a placebo. They found that all the drugs tested were significantly more effective than a placebo in the treatment of positive and negative symptoms. The findings of this study showed that the normalization of dopamine positively affects schizophrenia symptoms, and shows that dopamine plays a key role in schizophrenic symptoms, and this increases the support and appropriateness of the dopamine hypothesis. Neural correlates. Patterns of structure in the brain that occur in concurrence with an experience, schizophrenia. Neural correlates of negative symptoms, for example, avolition and the loss of motivation. The ventral striatum is believed to control this function. Studies have shown a negative correlation with activity levels in the ventral striatum and motivation. Neural correlates of positive symptoms, for example, of positive symptoms, e.g. PET scans have shown patients experiencing auditory hallucinations are linked with lower activation levels in the temporal lobe. AA3. Support for neural correlates of positive symptoms comes from Alan et al. He scanned the brains of patients experiencing auditory hallucinations and compared them to a control group whilst they identified pre-recorded speech as theirs to others. Lower activation levels in the superior temporal gyrus and anterior cingulate gyrus were found in the hallucination group, who also made more errors than the control group. We can thus say that reduced activity in these two areas of the brain is a neural correlate of auditory hallucination.